In this lesson, we're asked to solve the trigonometric equation cosine theta plus 1 equals sine theta in the interval 0 to 2 pi. Now this one is a bit different than the other equations, trigonometric equations we've looked at so far, in that we have both a cosine theta and a sine theta to deal with. So one of the things I remember is that I know information about cosine squared theta plus sine squared theta. So my trigonometric identity, my Pythagorean trigonometric identity tells me that cosine squared theta plus sine squared theta is 1. So if I had a term involving cosine squared plus sine squared, I could simplify that to 1. I certainly don't have that yet, but let's think about how we might be able to get there. So the first thing I'm going to do is go ahead and bring my cosines and sines to one side and my constants to the other. So this becomes cosine theta minus sine theta equals -1. And again, my thought process here was, well, perhaps I could simplify this by getting a cosine squared plus sine squared. So I'm going to square both sides of this equation. We get cosine theta minus sine theta all squared equals -1 squared. On the left, we get cosine squared theta minus 2 cosine theta sine theta plus sine squared theta. And on the right, we get -1 squared, which is 1. So next, notice that this introduced a cosine squared plus sine squared. So those terms combine to give me 1. So we end up with 1 minus 2 cosine theta sine theta equals 1. Of course, we can now subtract 1 from both sides to get -2 cosine theta sine theta equals 0. And now we can use our zero factor property, which tells me that a product of terms is equal to 0 only when one or both of the individual terms is 0. So I get that this equation is satisfied when cosine theta equals 0 or sine theta equals 0. So in this problem, we were asked to solve on the interval 0 to 2 pi, so we don't have to worry about going around and around the circle like we did before. So let's start with cosine theta equals 0. When will that happen? So on my unit circle, when is the x-coordinate 0? So that's going to be at pi over 2 and 3 pi over 2. So my 90 degrees and 270 degrees. And what is my y-coordinate, sine of theta equal to 0? Well, that's at 0 and pi, or 0 and 180 degrees. So I have pi over 2, 3 pi over 2, 0, and pi. But remember here that I squared both sides of the equation in this step. And whenever we square both sides of an equation, we need to check whether or not we've introduced extraneous solutions. So we need to check whether or not these solutions all actually work. So let's just start with pi over 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So we get 0 plus 1 equals 1, so pi over 2 works. 3 pi over 2. Cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is -1. So plugging in 3 pi over 2 would give me 0 plus 1, or 1 on the left, and -1 on the right. So 3 pi over 2 does not work. What about 0? So cosine of 0 is 1. Sine of 0 is 0. So on the left, I'd be getting 1 plus 1, or 2. On the right, I'd be getting 0. So 0 does not work. And what about pi? Cosine of pi is -1. So I'm getting -1 plus 1 is 0 on the left. Sine of pi is 0. So I get 0 on the right. So pi works as well. So I get as our final solution pi over 2 and pi for our solutions of this equation in the interval 0 to 2 pi. And again, the key observation here was to think about, well, I've got both cosines and sines to deal with, so I'll think about squaring so that I can use one of my identities, the cosine squared plus sine squared is 1, and then I remember that whenever we square both sides of an equation, we do need to check to see if we've introduced extraneous solutions, as we did here. So our final answer here is pi over 2 and pi.